Hello. In this video, I want us to look at exponentials from a bit of a different perspective. What if we're given the graph and we need to figure out the equation? So here, for example, we have y equals b to the x. We know it's just a basic exponential because they've told us the equation, but they haven't told us what the equation is. Is it 2 to the x, 3 to the x, 4 to the x? Who knows? What we have to do is figure it out. And it's definitely important to go ahead and find some points on the graph. So there's a point here at 0, 1. But that doesn't really tell us anything because every exponential goes through 0, 1 if it hasn't been transformed. But we have a point over here at 1 and 4. And I think that's going to help us figure out the base. If we plug that point into the equation, we get 4 equals b to the power of 1, which means 4 equals b. Therefore, b is 4. And so our equation is y equals 4 to the power of x. This point right here was able to help us determine the type of exponential. Now, obviously, we have to make it a little more difficult. So here we have an exponential where we know that it's just a basic base, but it has been transformed with a minus c. That means it's been translated horizontally. And we can see that because it doesn't have a point at 0, 1. Now, let's go ahead and say, okay, well, we've got a point here at 2 and 1. We've got a point here at 3 and 2. We've even got a point over here at 4 and 4. What type of exponential do we have? What's going on here? Well, one thing we can do is we could plug in some of these numbers. So if we plug in the first one to the equation, we get 4 equals b to the 4 minus c. But if you notice, that equation has two variables. It has a b and a c. So let's plug in another equation. Let's do 2 equals b to the 3 minus c. Oh, darn. Again, we have two variables. It's a little tricky when you have an equation with two variables. You can't solve it right away. But what you can do is you can take these two equations and you can divide the equations. You might not have seen this before. It's a nifty little trick. Normally we add or subtract equations, but you can actually divide equations. Let's go ahead and see what we get. If we take 4 divided by 2, that's going to give us 2. If we take b to the 4 minus c divided by b to the 3 minus c, well, let's write that out. b to the 4 minus c, b to the 3 minus c. Because we're dividing and they have the same base, we're allowed to subtract the exponents. So using exponent rules, this gives us b to the 4 minus c, and then we subtract 3 minus c. So we get 2 equals b to the 4 minus c minus 3 plus c. And the c's cancel. 2 equals, well, 4 minus 3 is going to be 1, and we get b equals to 2. Now, I know that was a little weird, but it's a kind of interesting technique. If you have 2 points or 3 points or however many points you have, you can go ahead and plug them in just like normal and then divide the equations to figure out the missing b value. Now that we know the missing b value, we can take this and plug it into any equation we want. And we'll go ahead and get 4 equals 2 to the 4 minus c. And we can solve this like a regular exponential. So 2 to the 2 equals 2 to the 4 minus c. We drop the base and we get 2 equals 4 minus c. So c equals 4 minus 2. So c is equal to 2. So therefore our equation is y equals 2 to the x minus 2. And you can kind of see this here because, well, if we start at the beginning, if we kind of imagine this as the beginning point, it used to be on the y-axis, and it's been moved over 2. And we can also see the graph is kind of going up based on doubling. Each time we go over the y values, doubling and doubling. So it's a base 2 exponential. All right, so I'll give you guys a real tough one. Go ahead and try this one on your own. You've got y equals b to the x minus c plus d. We have 3 points, 2, 2, 3, 3, 4, 5. Go ahead and plug in the points and try to solve for the exponential equation. All right, so assuming you've given this a try, you should have something like this. When you plug in the point 2, 2, you get 2 equals b to the 2 minus c plus d. Then if you plug in 3, you get 3 equals b to the 3 minus c plus d. Or you get 5 equals b to the 4 minus c plus d. Now, what we should do is we should solve for d first. And I mean, we do have 3 equations here, so you could do sort of 3 equations, 3 unknowns, but it's a little bit easier to actually look right here. If we look at the graph, we can see that there is a horizontal asymptote at y equal to 1. And so that means d has to be equal to 1 just based on that feature. If we use that, we can actually go back here and we can fix up our equation. Instead of having plus d, we'll just have plus 1. Now, we don't actually need to use all of the equations here. We could just use these last 2. And we'll go ahead and divide them. But I think it would be easier before we divide them to isolate for the exponential. We don't want to have that plus 1 there. We want to move the plus 1 over to the other side. So that's going to give us the following. 2 equals b to the 3 minus c. And 4 equals b to the 4 minus c. Now if we divide them, 4 divided by 2 is going to be 2. Equals b to the 4 minus c over b to the 3 minus c. That means we have 2 equals b to the 4 minus c minus 3 plus c. So 2 equals b to the 1 or b equals 2. So just like the other question, we definitely have b equal to 2. And if you take that and plug it into any of the equations, you should find c equal to 2 as well. So our final equation will be y equals 2 to the x minus 2 plus 1. All right, here's one that's got all sorts of fun things going on. We have a giant graph. We have a b to the x minus c plus d. And again, we need to determine those 3 values. So go ahead and pause the video, give it a try, and then we'll check your answer. All right, so similar to the last one, we should definitely look at that horizontal asymptote. The horizontal asymptote is at y equals negative 4, and so that means d is equal to negative 4. Now let's go ahead and plug in some points. So we have negative 3 equals b to the negative 2 minus c minus 4. And we have negative 1 equals b to the negative 3 minus c minus 4. So we'll go ahead and rearrange those equations by getting the d to the other side. That'll give us 1 equals b to the negative 2 minus c, and 3 equals b to the negative 3 minus c. That's add 4 to both sides. Right, taking that negative 4 and moving it on over. So now we can divide the equations. So we'll get 1 divided by 3 is 1/3. B to the negative 2 minus c over b to the negative 3 minus c. So 1/3 equals b to the negative 2 minus c plus 3 plus c. Those c's cancel. And you get 1/3 equals to b. So now we have our b value, we have our d value. Finally, you can go ahead and solve for c. I'll just do that up over here. So we get 1 equals b to the negative 2. Oh, now we know the b. So 1 equals 1/3 to the negative 2 minus c. Now again, this is a bit of a weird equation. Maybe this one isn't the easiest to use, but we know that 1 is equal to 1/3 to the 0. And so we can treat this just like our exponential equations that we're used to solving. So we get the same base with a little cheat there, 1/3 to the 0. We drop the base, we get 0 equals -2 minus c. So c equals -2. And so our final equation then is y equals 1/3 x to the -2, which means we'd write minus -2 or +2, and then -4. All right, one last problem here. You can take notes on this one. I'm going to tell you that y equals b to the x minus c plus d. I'll give you 2 points and the asymptote. Your job is to determine the equation. All right, so hopefully you gave that a try. Instead of giving you the graph, I'm just giving you the points, but it should be the same approach. This tells you that d equals equals -1. Here, your 0.24 and 10 can be plugged in, so we get 4 equals b to the 2 minus c minus 1, and 0 equals b to the 1 minus c minus 1. We go ahead and move the -1 over, so we get 5 equals b to the 2 minus c, and 1 equals b to the 1 minus c. Then we divide, and we get 5 equals b to the 2 minus c over b to the 1 minus c. So 5 equals b to the 2 minus c minus 1 plus c. And so b equals 5. Finally, we take that and solve for c. So 4 equals 5 to the 2 minus c minus 1. 5 equals 5 to the 2 minus c, so we'll call that 5 to the 1. Drop the base, and you get c equals 1. So our final equation is y equals 5 to the x minus 1 minus 1. And if you wanted, you could check this on Desmos. It would indeed go through these points and have the following asymptote. So for practice, you can try Unit 8, Worksheet 7, and 7.5. Hopefully you enjoyed graphing these exponentials. And as always, thanks for watching.